we're asked to solve the log of x plus log of 3 is equal to 2 log of 4 minus log of 2. So let me just rewrite it. So we have the log of x plus the log of 3 is equal to 2 times the log of 4 minus the log of 2, or the logarithm of 2. And just as a reminder, whenever you see a logarithm written without a base, the implicit base is 10. So we could write 10 here, 10 here, 10 here, and 10 here. But for the rest of this example, I'll just skip writing the 10 just because it'll save a little bit of time. But remember, this literally means log base 10. So this expression right over here is the power I have to raise 10 to get x. The power I have to raise 10 to get 3. Now with that out of the way, let's see what logarithm properties we can use. So we know if we, and these are all the same base, we know that if we have log base a of b plus log base a of c, that this is the same thing as log base a of bc. And we also know, so let me write all the logarithm properties that we know over here. We also know that if we have a logarithm, a log, let me write it this way actually. If I have b times the log base a of c, this is equal to log base a of c to the b power. And we also know, and this is derived really straight from both of these, is that if I have log base a of b minus log base a of c, that this is equal to the log base a of b over c. And this is really straight derived from these two right over here. Now, with that out of the way, let's see what we can apply. So right over here, we have all the logs of the same base, and we have logarithm of x plus logarithm of 3. So by this property right over here, the sum of logarithms with the same base, this is going to be equal to log base 10. So I'll just won't even, well, I'll write it here. Log base 10 of 3 times x, of 3x. Then based on this property right over here, this thing can be rewritten. Let me say, so this is going to be equal to, this thing can be written as log base 10 of 4 to the second power, which is really just 16. So this is just going to be 16. And then we still have minus logarithm base 10 of 2. And now, using this last property, we know we have one logarithm minus another logarithm. This is going to be equal to log base 10 of 16 over 2, right? 16 divided by 2, which is the same thing as 8. So the right-hand side simplifies to log base 10 of 8. The left-hand side is log base 10 of 3x. So if 10 to some power is going to be equal to 3x, and 10 to the same power is going to be equal to 8, so 3x must be equal to 8. 3x must be equal to 8. 3x is equal to 8, and then we can divide both sides by 3. Divide both sides by 3, you get x is equal to 8 over 3. One way, this little step here, I said, look, 10 to the, this is an exponent. If I raise 10 to this exponent, I get 3x. 10 to this exponent, I get 8. So 8 and 3x must be the same thing. One other way you could have thought about this is, let's take 10 to this power on both sides. So you could say 10 to this power, and then 10 to this power over here. If I raise 10 to the power that I need to raise 10 to get the 3x, well, I'm just going to get 3x. If I raise 10 to the power that I need to raise 10 to get 8, I'm just going to get 8. So once again, you got the 3x is equal to 8, and then you can simplify. You get x is equal to 8/3.